Good morning, friends. I hope you are doing well, and I request everyone to watch my videos in a sequence for better understanding. Let me solve one gate question which came in 2020. Consider the following language L. X belongs to A comma B whole star, meaning is that string can be generated with alphabets A comma B. If such string belongs to language L, the number of A's in the string X is divisible by 2 but not divisible by 3. So if you take any string which belongs to language L, the number of A's should be divisible by 2 but not divisible by 3. The best example is 4 A's. 4 A's in the string is divisible by 2 but not divisible by 3. Then they are asking the minimum number of states in DFA that accepts is, they are asking you find the minimum number of states in the DFA that accepts. Okay. So now I need to solve this question. How I can solve this question? If I take it as a big question, it cannot be solved because you need to take a lot of complexity. So let me segregate the question into two parts such a way that I can solve the two parts and then again I can rejoin them. Similar kind of question I have solved in the earlier video. What is that question? I have taken the even number of A's and even number of B's. Then what I have done? Even number of A's I have solved first. Then even number of B's I have solved first. Then I combined both the DFAs and I got the final DFA. Okay, if you have not watched the video, I request you to watch the video and come back to this video for better understanding. First, let me solve it. The number of A's in X should be divisible by 2. If you see that entire question, they are not keeping any restriction on the number of B's. Only number of A's should be divisible by 2 but not divisible by 3. So first I will take the number of A's in X divisible by 2. If the number is divisible by 2, then you will get initial state will act as a final state. Even 0 number of A's also divisible by 2. If it is 1A, I should not accept. If it is 2 A's, I should accept. And there is no restriction on the B, so I can keep it like this. Okay. If you want to check it whether it is correct or not, you take the BAAB. So the number of A's in this one is 2, which is successfully divisible by 2. So let me take it. Q0 on B, it is going to Q0 itself. Q0 on B, it is going to Q0. Q0 on A, it is going to Q1. Q1 on A, it is going to Q0. Q0 on B, it is going to Q0 itself. So Q0 is a final state or non-final state? Q0 is a initial state and also final state. So Q0 is the final state. So I can say that the string is accepted by the DFA. Let me take a counter example. AAAB, or let me take it simply only AB. AB consists of only one A which is not divisible by 2. Okay. So let me take the initial state Q0. From Q0 on A you are going to Q1. Q1 on B it is going to Q1 itself. Now Q1 is a final state. No, Q1 is a non-final state. As Q1 is a non-final state, I can say that the string is not accepted by the DFA. So what are the strings it is accepting by this DFA? Where the number of A's are divisible by 2 and it is not accepting which are not divisible by 2. If you want to check it, you can check it. Then you can ask me why you kept initially B. There is no restriction on the number of B's. Okay, B on 2 A's also should accept, or A, B, A also should accept, or A, B, B, A also will accept because the number of A's are 2. Okay, so I hope you have understood how I got this DFA. Let me denote this one as D1. Okay, now we will solve the next one. Not divisible by 3. So the DFA where the number of A's should not be divisible by 3. If the number of A's divisible by 3, what are the reminders I will get? If I do the mod 3, the number of A's, if I mod 3, I can get the remainder 0. I can get the remainder 1 or I can get the remainder 2. But if I get the remainder 0, then what I can say, it is successfully divisible by 3. Am I right or wrong? Any number, if I divide with any number, any other number, if I get 0, I will say that it is successfully divisible. but they are saying that not divisible by 3. So you should not get the remainder as 0, but you can get the remainder 1 and you can get the remainder 2. If you get some remainder, then you will say that it is not divisible by that number. Okay. So if you want to get 1 as a remainder, then the number of A's can be single A, because if it is 1 A, you will get remainder as 1, or it can be 4 number of A's, or it can be 7 number of A's, or it can be 10 number of A's, so on. If you want to get the remainder as 2, the minimum is 2 A's will be there, or 5 A's can be there, or it can be 2, 5, then 8 number of A's, 11 number of A's, all these number of A's can come into this one. Okay, so let me construct this one. As the number is not successfully divisible by 3, so your initial state will not act as a final state. So your initial state will be Q2 only. And on a single A, you should accept. Why? Because if you get a 1A and if you divide by 3, you will get remainder 1. So it is not successfully divisible. So single A is not successfully divisible by 3. So I can say that it should be accepted. If it is 2 A's, meaning is that from initial state after reading 2 A's, let's take that. Then whether it is successfully divisible by 3? No. So even I should accept this one. So let me write it as Q4. Now if you read another A from here, then how many number of A's coming? 1, 2, 3. If it is 3 A's, it is successfully divisible by 3. But it should not divisible by 3. So it will not act as a final state. So Q2 is not a final state, whereas Q3 and Q4 are the final states. What about the number of B's? There is no restriction on the B's, so I can directly write like this. Is it clear? There is no restriction on the B's. Now we will check it. Whether let's take in this string B, A, B, A. Whether it is successfully divisible by 3? No, it is not successfully divisible by 3 because the number of A's are here is 2. So let me take it. From the initial state Q2, on B where I am going to a state called Q2 alone. Q2 on B I am in Q2. Q2 on A I am going to Q3. Q2 on A I am going to Q3. Q3 on B, Q3 itself. Q3 on A I am going to Q4. Whether Q4 is a final state? Yes, Q4 is a final state. So this string, which is the number of A's is not divisible by 3, is accepting by DFA. Let me take a counter example. 3AB. Okay, the number of A's are divisible by 3, so my DFA should not accept. Let's check it whether it is accepting it or not. Q2 on A, where it is going? Q3. Q3 on A, it is going to Q4. Q4 on A, it is going to Q2. Q2 on B, it is going to Q2. So finally, from the initial state after parsing the entire string A, B, you are reaching to a state called Q2, where Q2 is a non-final state. If you are reaching to the non-final state, what I can say? The string is not accepted by the DFA. So this is a minimized DFA for not divisible by 3, and this is the minimized DFA for divisible by 2. Now what should I do? They are asking that the number of A's in X is divisible by 2 but not divisible by 3. Meaning is that you should consider that if there is an AND is there. Okay. So if there is an AND, we can have to combine these two. Okay. How I can combine is that by applying the cross product. How I will apply the cross product? Take the states which are there in the DFA D1 and take the states which are there in the DFA 2 and apply the cross product. If I apply the cross product, there are 2 states are there, there are 3 states are there. If I apply the cross product, I will get 6 states. What are the 6 states is Q0 Q2, Q0 Q3 and then Q0 Q4. Similarly, you will have Q1 Q2, Q1 Q3, Q1 Q4. So you will get 6 states. Let me write what are the 6 states. Q0 Q2, Q0 Q3, Q0 Q4, then Q1 Q2, Q1 Q3, Q1 Q4. These are the 6 states, you will get it. So let me construct the minimize DFA means, so if you combine you will get 6 states. So then what I can say, the final DFA will have the minimum number of states in DFA is 6. We will check it whether we are getting those 6 states or not. We are getting the 6 states. So the answer is 6. But now I want to complete the question. Here someone who is solving the gate question and the exam, you can stop here and you can say that the correct answer for this one is 6. Okay, but as you are beginners and I want to show you the entire question, let me solve the entire question. Okay, so how I can solve? I will take all the 6 states. You have Q0, Q2, you have Q0, Q3. Let me take here Q0, Q2, Q0, Q3, Q0, Q4. You have Q1, Q2, Q1, Q3, Q1, Q1, Q4. These are the 6 states you have. Now how can I construct the DFA? Because when I can say that it is a DFA, there are some moves are there on A and B from the each state. Now how can I get it, the states? Now check it. I need to find on Q0, Q2 on A where it is going. Because on Q0 and Q2, I need to represent a transition on A and similarly transition on B. How can I get on a transition on A? You need to check Q0 on A, where it is going, Q1. Q2 on A, where is Q2 is there? Q2 is there here. Q2 on A, it is going to Q3. So it is going to state called Q1, Q3 on A. Are you able to follow it or not? Q0 and Q2 on A you need to find. So take the Q0, it is here. Q0 on A you are going to Q1. Q2 on A you are going to Q3. So from Q0, Q2 on A you are going to a state called Q1, Q3. So where it is here. So you do it. Similarly on B, if you check it, Q0 on B it is going to Q0. Q2 on B it is going to Q2. So Q0, Q2 on B is going to Q0 and Q2. So I will write here like this. On B it is going. Okay. Now Q0, Q3 on A where it is going. Q0, Q3 on A. Q0 on A Q1. Q3 on A it is going to Q4. So on A, Q0, Q3 on A it is going to Q1, Q4. Is it clear? Q0 on A is going to Q1, Q3 on A it is going to Q4. If you see that Q0 on B is going to Q0, Q3 on B is going to Q3. So I can say that Q0, Q3 on B it is going to itself. Now Q0, Q4. Q0 on A is going to Q1. Q4 on A it is going to Q2. So it is going to Q1, Q2. Q4 on A it is going to Q1, Q2. Are you able to understand? Then Q0, Q4 on B it is going to itself. You can check it. Q0 on B it is going to Q0. Q4 on B it is going to Q4. Now similarly we will check Q1, Q2. Okay. Q1, Q2 on A where they are going. Q1 on A Q0. Q2 on A it is going to Q3. So Q1, Q2 on A is going to Q0, Q3. Where it is here. So let me write here. Okay, Q1, Q2 on A it is going to itself. Q1, Q2 on B it is going to Q1, Q2 only. Now Q1, Q3. Q1, Q3. Q1 on A it is going to Q0. Q3 on A it is going to Q4. So it is going to Q0, Q4. Let me write like this. It is a A. On B it is going to itself. Okay. It is little bit clumsy but you can draw it properly. Now Q1, Q4 on A. Q4 on A where it is going? Q4 on A it is going to Q2. So from Q0, Q4 on A. So Q1, Q4 on A you are going to Q0, Q2. Is it clear? Are you able to understand? On B it is going to itself. little bit clumsy, but I think if you saw my previous video, you can do it by yourself. So I have draw like this. So now what is the initial state? What are the states which are acting as an initial state here? Q0, Q2 are the initial state. So in this DFA, Q0, Q2 will act as the initial state for you. Okay. Now what are the states are acting as a final states here? In this DFA you have Q0 as the final state, and in this DFA you have Q3, Q4. So what I can say, Q0, Q3, Q0, Q4 will act as a final states in this DFA, because if I combine them, you will get Q0, Q3, Q0, Q4 are the two states which will act as a final state. So Q0, Q3, Q0, Q4 will act as a final state. So this is the minimized DFA for this question, and you got 6 states. Now we will check whether it is correct DFA or not. Now we will check whether the constructed DFA is correct or not. Okay, how can I check? I will take a string where the number of A's is divisible by 2 but not divisible by 3. Okay, so if you take that this string belongs to this long base, how can I say it is divisible by 2 but the 4 is not divisible by 3, so it is a correct one. So if the string belongs to long base L, my DFA should accept this string. When I can say that the string will be accepted after traversing from the initial state to the final, means from taking the initial state, if I take this string, I have to reach to a final state, any one of the final state. There are 2 final states are there. Then I will say that it is a correct DFA and it is accepted. Now we will check. What is the state I am in? I am in state called Q0, Q2. Q0, Q2 on A, it is going to Q1, Q3. On A, it is going to Q1, Q3. Is it clear? Now Q1, Q3 on A, it is going to Q0, Q4. If you see that Q1, Q3 on A, it is going to Q0, Q4. Q0, Q4 on A, it is going to Q1, Q2. If you see that there is Q0, Q4 on A, it is going to Q1, Q2. Q1, Q2 on A, Q1, Q2 on A, it is going to Q0, Q3. Now Q0, Q3 on B, it is going to Q0, Q3. Now from the initial state Q0, Q2, by traversing the string, we have reached a state called Q0, Q3. We need to check whether Q0, Q3 is a final state or not. If you see that Q0, Q3 is a final state, so the string which belongs to long base L is accepted by DFA. Now we will see the counter one, means a string which does not belongs to long base L, whether it is accepting or not. When I can say that for a long base L, this is a correct DFA, what are the strings which belongs to long base L should be accepted, and what are the strings which does not belongs to long base L should not be accepted. So we will take a string which does not belongs to long base L. Tell me the number of A's which are divisible by 2 but divisible by 3 also, because I am taking a counter example, because they are saying but not divisible by, I am taking a counter one divisible by 3 also, divisible by 2 and divisible by 3, so you will get 6 A's. So take the 6 A's. Okay, I will not take the B's, because B's there is no count. Even if you want to take B, you can take it. Okay, so 6 A's will be divisible by 2 and also divisible by 3, so that I can say that it does not belong to long base L. So I am in the initial state Q0, Q2. Q0, Q2 on A, where you have reached Q1, Q3. Q0, Q2 on A, you have reached Q1, Q3. Q1, Q3 on A, Q0, Q4. Q0, Q4. Q0, Q4 on A, you have reached Q1, Q2. If you see that Q0, Q4 on A, you have reached Q1, Q2. Q1, Q2 on A, where you have reached Q0, Q3. Now Q0, Q3 on A, Q0, Q3 on A, you are going to Q1, Q4. Okay. Now this is this one, Q1, Q4. Now Q1, Q4 on A, where you are going? Q0, Q2. Are you able to understand? See, let me discuss again. From initial state on taking 1A, you have reached Q1, Q3. I have represented here. Q1, Q3 on A, where you have went Q0, Q4. Now, if you are seeing the third A, Q0, Q4 on A, you came to Q1, Q2. So, from initial state after traversing 3 A's, you reached Q1, Q2. Q1, Q2 on A, you have reached Q0, Q3. 4 A's are gone. Okay. Now, fifth A, Q0, Q3 on A, you are reaching Q1, Q4. Now, sixth A, Q1, Q4 on A, you are going to Q0, Q2. Q0, Q2 on B, you are again going to Q0, Q2 only because it is on this state. Now check it. Q0, Q2 is a final state or non-final state? Q0, Q2 is a non-final state. So what I can say, the string will not be accepted by the DFA. So if you see this, it is accepting the strings which belongs to language L, and it is not accepting the strings which does not belongs to language L. So I can say that this is the correct DFA, and the answer for this question is minimum is you will get 6. If you see 1, 2, 3, 4, 5, 6. Okay. Now let me tell you a simple shortcut. People usually, those who are very familiar with the gate, they will not do this much. How they will do is that number of X is divisible by 2. So you will get 2 states. Number of states which are divisible by 3 but not divisible by 3. So you will get 3 states. 2 into 3, 6 states. They will not construct this one. They will not construct the DFA. Entire procedure they will not do. Because they will say that any DFA which is divisible by something, then it will be L. Suppose if you see that divisible by 4, then you will have minimum is 4 states. Divisible by 5, you will have 5 states. Okay. And not divisible by 3. Not divisible by 3 also you will have 3 states, whereas the final states will change, but you will have 5 states. So 2 into 3, you will get 6 states. So they will write answer directly 6 without solving it. By practice, you can also answer directly. I request everyone to practice all the questions, what are the variants I am discussing. You try to find some new questions and try to solve it. If you cannot solve it, you send the question to me in the comment section. Then I will solve it and send back to you. Thank you so much.